now we'll study about hi student. Now we'll study about electric flux and Gauss theorem. So electric flux, the number of electric lines passing through a surface of electric field is known as a electric flux. Number of electric lines is passing through a surface is known as a electric flux. Electric flux is classified into two categories: positive electric flux and second is negative electric flux. Clear? So electric flux plays important part in a Gauss theorem. So our main motto to first understand about electric flux. So electric flux generally it is represented by phi and its value is EDS, means you can see that E is the electric field intensity, DS means surface, means electric lines is passing through a surface. Now we are going to discuss about Gauss theorem. Gauss theorem, Carl Friedrich Gauss stated that the net electric flux of any closed surface, closed means like that, no? We have studied earlier classes closed surface. The net electric flux for any closed surface, this is the closed surface. The net electric flux for any closed surface is 1 upon epsilon times of net charge present it. Means if the charge is Q, then it will be phi E equal to 1 upon epsilon naught into Q. Means the net electric flux for any closed surface is 1 upon epsilon naught times of net charge present inside it. So we know that electric field intensity, we have a diagram. First we'll understand. This point is O. To the distance R we have a point P. Here where electric field intensity, we know that E equal to 1 upon 4 pi epsilon naught Q upon R square. And this is the surface ds, and electric field intensity, we know that E equal to 1 upon 4 pi epsilon naught Q upon R square. Also we have discussed that what is electric flux formula? Phi E equal to EDS cos theta. Okay, so we are taking very less amount of electric flux. Okay, d phi E. So d phi E equal to EDS cos theta. So if we are putting the value of E in equation first, we can say E equal to d phi E equal to 1 upon 4 pi epsilon naught Q upon R square ds cos theta. Okay, so this is the value of d phi E. Now we know that we are going 1 upon 4 pi epsilon naught Q, and we are separated R square with the ds cos theta upon R square. ds cos theta upon R square, we know that d omega. Okay, so in place of ds cos theta upon R square, we will put d omega. Then we this is for the small element. If we are going to do the whole, we are going to get whole electric flux, then we have to integrate this small element. Then phi E equal to integration of whole integration of d phi E. So we are putting the d phi E's value by equation second. Okay, this suppose this is our second equation. We are putting the value of d phi E by equation second. We'll get d phi E 1 upon 4 pi epsilon naught Q into d omega, because this is the constant, so we are not getting that whole integration of, only will be there for d omega. So 1 upon 4 pi epsilon naught Q whole integration of d omega. We know that d omega's value, d omega is a solid angle which is made by, its value is 4 pi. So in place of d omega, we'll put 4 pi. Phi equal to 1 upon 4 pi epsilon naught Q into 4 pi. 4 pi, we will cancel 4 pi to 4 pi. Then we'll receive that phi equal to Q upon epsilon naught. If we are getting the medium, which is dielectric medium is K, then phi equal to Q upon K epsilon naught. So this is our Gauss theorem. So once again I will give you short review that Carl Friedrich Gauss stated that the net electric flux for any closed surface is 1 upon epsilon naught times of net charge present inside it. So we know that electric flux is the number of electric lines passing through a surface. It is known as a electric flux.